This is Math Studies, Lesson 10.4. In this lesson, we're going to talk about measures of spread or variation, deviation. Those are all different words that mean the same thing. The first measure that we're calculating is the range. The range is the maximum value of the data set minus the minimum value of the data set. The interquartile range is the third quartile or the upper quartile minus the first or lower quartile. The standard deviation is kind of complicated. In words, what it says is that you take the mean of a set of data and you get the difference between the mean and each of the scores. After you have all of the differences, you square the differences, get the mean of the differences, and then square root the mean. So we'll do an example of that down below. The last piece of the notes is outliers. So an outlier is a data point that is significantly different from the rest of the data. Now there's different rules on what constitutes significantly different. We're going to use the mathematical rule of being more than 1.5 interquartile ranges from the quartiles. So a data value is a lower outlier if it is less than the first quartile minus 1.5 interquartile ranges. And a data value is an upper outlier if it is greater than the third quartile plus 1.5 interquartile ranges. So this value would give you lower outliers, and then this data value would give you upper outliers. And we'll do all of these as examples below. So the first example says, consider the data set 2, 5, 4, 6, 7, 5, 6. Find the range. Range is maximum minus minimum. So my maximum value is 7. My minimum value is 2. So the range here is 5. The next question says find the interquartile range. I think I need to order these before I can really do that. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, so I already had the max and the min. If I'm trying to find the median, 5 is the median. And then when I go back and find the quartiles, 4 is the lower quartile, and 6 is the upper quartile. So the interquartile range is 6 minus 4, which is 2. Standard deviation, that was a long one. So the first thing I need is the mean. If I add up all of my numbers, I get 35 over 7 numbers. My mean is 5. So after I get the mean, my formula tells me to get the difference between the mean and each data point. So what I'm going to do is just say how far is each one of my 7 numbers? How far is it from 5? So 2 is 3 from 5. 5 is 0 from 5. 4 is 1 from 5. 6 is 1 from 5, 7 is 2 from 5, 5 is 0 from 5, and 6 is 1 from 5. How far each of my values is from the mean. Then we square each of those differences. That is 9, 0, 1, 1, 4, 0, 1. Then we get the average of those, so we're going to add them all up and divide by 7. And 16 over 7 is 2.29 if I round that. And the last step is to square root that value. The square root of that is 1.51. So that is a pretty complicated calculation. That is the average distance of all of the points from the mean. Letter B says, determine if there are any outliers. So that's asking, are there any data values that are significantly different from the rest? And 1 of 5 seems pretty out there, but we'll go through the calculations just to be 100% sure. So I need my quartiles. I think I messed that up. Okay, quartiles. Median, Q1, Q3. So a lower outlier would be less than 8 minus 1.5, 44 minus 8. And an upper outlier would be greater than 44 plus 1.5, 44 minus 8. The first one is negative 46. So the question is, are any of the data values less than negative 46? No. No lower outliers. The upper boundary is 98. Are any of the data values greater than 98? Yes. 105 is an outlier. Okay, that is it for the notes. Good luck on the exercises, and please let me know if you have any questions.